All right. Hey guys, so I am out today, but we still have some stuff to do. So let's start off with a warm up. So if this first problem with 9x squared plus 24x plus 16, there is no GCF. So if there's no GCF, we're going to want to just do our X method and grouping. So the first thing that we're going to want to do is we're going to want to multiply 9 times 6. So 9 times 16 is 144. So that's going to go on the top of our X. And then once we have that on the top of our X, okay, we're going to put 24X on the bottom. And right now my smartboard's giving me some issues. Okay, here we go. I think. We'll see. See what happens. There we go. Okay, sorry about that. So it's 144x squared on top and 24x on the bottom. So since 144 is positive and so is 24, it's going to be plus plus. So now we just have to think about the factors of 144 that add up to 24, and they're actually 12 and 12. So we have 9x squared plus 12x plus 12x plus 16. Now we're going to group. 3x is our GCF, leaving us with 3x plus 4. 4 is our GCF, leaving us with 3x plus 4. So you'll notice that both of our factors are 3x plus 4, so we can write that simply as 3x plus 4 squared. So there's our first warm-up problem. For our second warm-up problem, there is a GCF of 2. That's going to leave us with 2x squared minus 13x minus 7. Now we're going to factor. 2x squared times negative 7 is negative 14x squared. Negative 13x goes in the bottom, so since negative 14 is negative, opposite signs. And that's going to be negative 14x and positive 1x. So we have 2, and then 2x squared minus 14x, all right, plus 1x minus 7. So GCF of our first group is 2x, leaving us with x minus 7. GCF of the second group is 1, leaving us with x minus 7. So we have 2x minus 7 and then 2x plus 1. All right, so those are our factors. Okay, so homework check from last class. So those are the answers to your homework. If you have any questions, just kind of put a star beside them, maybe talk them out amongst each other and see if you can figure it out. And if you can't, keep that star and ask me when I return. All right, so for today's lesson, we're going to take some notes here on solving logs and exponential equations. Sorry about the bell. Hang on just one second. All right. So, solving exponential equations without logs, okay? So here's our rule. Our rule is that if you have a to the m power equals a to the n power, then m equals n. So if the bases are the same, we're going to set our exponents equal to each other and solve. So it's pretty simple. If you look at your first example, our base for each is 5, so I can set my exponents equal. X equals 3. Done. Solved. My second example, once again, my bases are both 10, so I can set 1 minus x equal to 4. I'm going to add add x to both sides, leaving me with 1 equals x plus 4, and then subtract 4 from both sides, leaving me with negative 3 equals x. All right, so now sometimes you might have to discover your base. Okay, so if you look at your first problem, we have 3 to the x equals 9. Now, a lot of us know that x is going to equal 2 there, but let's pretend we didn't know. It was a little bit more complicated. How else can we write 9? Well, 9 is the same as 3 squared. So really, this is my problem. 3 to the x equals 3 squared. Since our bases are the same, we can set our exponents equal, and x equals 2. All right, so our next one gets a little bit more complicated. We can't as easily figure out what it should be, except we should know that 3 to the third power will get us 27. So I have this. 27 is the same as 3 to the third power. So now that my bases are the same, I can set my exponents equal. So 2x minus 1 equals 3. I'm going to add 1 to both sides, leaving me with 2x equals 4, and then divide both sides by 2, leaving me with x equals 2. Here's my last one of this. So 64 is the same as 4 to the third power. So I can set since I have a same base of 4, I can set 3 equal to 2x, divide both sides by 2, and we get x equals 3 halves, or 1.5. Okay? Now, the next one says, how can you solve for something in the exponent? Well, you can take the log of both sides. So this works when you see the next problem, you see that it's 2 to the x equals 30. Well, 2 to no power is going to get you 30. So we're going to have to use a different method than the one we just learned. So here are our steps right alongside here. Take the common log of each side. We're going to use the power property of logs, and then we're going to solve for x. Okay, so let's do that. So we have log. We're going to take the log of both sides. Now, the power property, what that says is that this exponent can come out front as the power. So log of 2 to the x is the same as x times the log of 2. And all of that's equal to the log of 30. Now, to solve for x, we're just going to divide both sides by the log of 2. So we have the log of 30 divided by the log of 2. We'll have to use our calculators for this, but we should get x is 4.9069 if we round it to 4 decimal places. Okay, so here are some examples. Feel free to pause the video, try them on your own, and listen to the example or of me explaining it. So for the first one, I'm going to take the log of both sides. Then I'm going to use my power property, and I'm going to bring that 3x out front. Then I'm going to divide both sides by the log of 7 first. Okay, and I'm going to want to leave that whole decimal in my calculator. So whatever that might be, so whatever the log of 20 divided by the log of 7 is, leave that in your calculator, and then divide both sides by 3. So you can get a more accurate answer. To the nearest, let's see, fourth decimal point, 0.5132. Okay, for our next example, I'm just going to shift that a little bit. So I'm going to do log of 3 to the x plus 4 equals log of 101. Power rule says I can take the x plus 4 out front, leaving me with log of 3 equals log of 101. Again, I apologize for the bell. And then we're going to divide both sides by the log of 3. Okay. And then we have x plus 4 equals log of 101 over log of 3. Again, keep it all in your calculator and then subtract 4 from each side. And if you do that, you get x is about 0.2009. All right. I'm just going to take these two problems down here since I'm running low on room. All right. So for the next one, take the log of both sides. Whoops, I'm so sorry. I can't take the log of both sides because I don't have it equal to anything. So what we actually want to do is we're going to change our f of x into 0. We're trying to find the solution of x, so we're going to set it equal to 0. Then I can subtract 2 from both sides. So now I have negative 2 equals 4 to the x minus 3. Now I can take the log of both sides. So the log of negative 2 equals the log of 4 to the x minus 3. Use my power rule here. So the log of negative 2 equals x minus 3 times the log of 4. Now we're going to divide both sides by the log of 4. And when you plug in the log of negative 2 divided by the log of 4, you're going to get an error because you can't take a log of a negative number. So there's an error. So for this one, there is no solution. All right, and then our last example right here, let's take, again, set it equal to 0. Add 3 to both sides. Take the log of both sides. use your power property. So log of 3 equals x plus 1 times the log of 5. Divide both sides by the log of 5. Again, keep all of that in your calculator. So don't round until the very end. And then you're going to have the log of 3 over the log of 5 equals x plus 1. So now we're just going to subtract 1 from both sides. And we get negative 0.3174. So those are our notes on logs today. The next few slides are just going to be some dry erase problems. Originally, that was what was planned. For you guys, just flip your notes over on the back and write down these problems. So feel free to pause the video whenever you need to. So first set of problems is 2 to the 4x minus 2 equals 64. The second problem is log base 4 of 3x minus 5 equals 3. Next problem is 1/3 to the 12 minus 5x minus 7 equals 123. Next problem is log base 2 of x squared minus 9 equals 4. And the last two problems, 5 to the 4x plus 2 equals 37,500. And then 4 log of x squared plus 7x minus 1 outside the parentheses equals 3. So do those problems first, and in the second video, I'll have the answers as well as your next part of the assignment.